Speaking about gravity, one cannot ignore such a theme as the famous Coral Castle, created by just one person, Edward Leeds Calman. Edward Leeds Calman himself called his structure Stonegate. In his video, I would like to draw attention to some of the details that Edward Leeds Calman offers us in his brochure Magnetic Current. Namely, manufacturing as Edward Leeds Calman called perpetual motion holder, or an electric magnet that keeps the eternal motion of the magnetic flux. What does Edward Leeds Calman offer us for creating this miracle? We look brochure offers to take iron as soft steel. That is, Edward Leeds Calman referring to electrical steel when talking about iron. Electrotechnical steel, it's iron with silicon additives up to 5%. Iron makes cores for transformers, stators for electric motors, cores for relays and much more. Soft steel is iron with carbon additives from 0.3 to 2%. If higher, the carbon additive of 2 to 4% is already cast iron. But it is brittle and not plastic like soft steel. We look at the drawing. We see a simple, horseshoe-shaped core closed by an armature and two coils of a copper wire. Let's conduct a series of experiments, which Edward Leeds Calman offers us with iron or electrical steel, as well as with soft steel, to preserve the eternal motion of the magnetic flux. We are conducting the first experiment with electrical steel. Experiment number 1. For the experiment, we take two horseshoe-shaped cores made of electrical steel from a conventional 500-watt transformer. Precisely combine the cores. We use a copper winding, 9 turns and a wire cross-section of 1 square millimeter. On a copper winding, we will supply a constant current from a source of 20 amperes. Have switched on the source, we look. We lift the structure. With 2 hands, we try to break the connection of the horseshoe-shaped cores to each other. Connection strong. It is not possible to break with both hands. We lift the structure, turn off the power supply. When the power supply is disconnected, we see an instant rupture of the horseshoe-shaped cores, as well as the disruption of the magnetic flux, which is dissipated into the surrounding space, ether. The experiment is very simple, understandable for physical understanding. Everyone can carry it out in his workshop. What conclusion can we draw from this experiment? The conclusion is very simple. Magnetic flow in a closed circuit, as Edward Leeds Calman himself called it. Perpetual motion holder, or an electric magnet that keeps the eternal motion of the magnetic flux in electrical steel, is not really preserved. Otherwise, just an ordinary transformer would not be able to work. In the core of the transformer for different types of electrical steel, saturation occurs at a frequency closer than 10,000 Hz. The magnetic flux in the core, after the electricity is cut off from the winding power supply, is not stored in the core, but instantly dissipates into the surrounding space, ether, which is confirmed by the demonstrated simple experience. Now remember the result of the first experiment. Experiment number 2. In the second experiment, we will proceed cunningly. Take from the first experiment only half of the horseshoe-shaped core made of electrical steel. Remember that the magnetic flux does not remain in it. Also, we take the anchor in the form of a bridge made of soft carbon steel. We put it on the horseshoe-shaped core and close it. Thus, the magnetic flux in the circuit will also pass through the anchor of electrical steel. The experimental conditions are the same as in the first. 9 turns of copper wire and a constant current of 20 amperes. Have switched on the source, we look. We took the anchor, raised. The construction is hanging. Turn off the source. The design does not disintegrate and continues to hang. The closed contour will hang endlessly, until the surface area, at the points of contact. The magnetic domains in carbon steel and electrical steel are oriented with each other. Now, we break the anchor. The anchor is no longer magnetized. There is a slight residual magnetization, which cannot affect the attraction. Once again, turn on and then turn off the power. The design continues to hang too. From the first experiment we know that in electrotechnical steel, in our case this is a horseshoe-shaped core, the magnetic flux dissipates into the outer space, ether. However, the details of the construction are attracted to each other. To confirm our experiment and the expanded understanding of the process, we continue our experiment using a second horseshoe-shaped core made of electrical steel. Third experience. Feed power to the coil, lift our design up. We see that all the details are related. With a little effort, we raise the upper horseshoe-shaped core upward with one hand. Then turn off the power from the coil. We see, as in the first experiment, an instant rupture of the upper horseshoe-shaped core occurs. I draw your attention to the fact that the gap occurs in the horseshoe-shaped core, where there is no coil. However, taking the anchor, we see that the anchor is drawn to the lower horseshoe-shaped core when lifting up. Magnetic domains are oriented with each other on the area in the part where the coil is located, which supplies the magnetic flux to the closed magnetic circuit. From the first experiment, as we already know, the magnetic flux is not conserved in a horseshoe-shaped core or electrical steel. Consequently, in a closed structure, there is no magnetic flux. However, after the power is turned off, as we can see, the anchor is attracted to the lower horseshoe-shaped core. The general conclusion from all three experiments: after the power is turned off, the magnetic flux is instantaneously dissipated from the magnetic circuit into the outer space, ether. Remaining magnetic domains remain in carbon steel, or mild steel as it was called by Edward Leeds Kalman himself. That is, soft steel, because of its properties, is like a one-time magnet. Residual magnetic domains are oriented to the surface of electrotechnical iron. The force of attraction depends on the surface area of the clutch. The larger the area between the parts, the greater the adhesion force. The strength of the clutch is even stronger if the whole structure consists of soft iron. When parts are broken, domains become multidirectional. And when you try to close the magnetic circuit, the parts are no longer attracted. Thus, the statement by Edward Leeds Kalman about the perpetual motion holder, or an electric magnet that preserves the eternal motion of the magnetic flux, does not, unfortunately, have physical grounds to its existence. Unfortunately, Edward Leeds Kalman did not understand the essence of the physical phenomenon, and the sincere was mistaken. Thank you for viewing. Your comments